Okay. Okay. My name is Aris Budi Wibowo. The title of my talk is Alternative A/B Testing Using Causal Inference to Measure Impact of Your Experiment. I hereby agree to abide by the Pycon APAC Code of Conduct and consent to being recorded and streamed.
Thank you. Good afternoon, everyone. Welcome to Pycon APAC 2024 in University Nahdlatul Ulama, Yogyakarta. We are on the second day in track 2. My name is Alin, and I will be your moderator for today's session. It's my pleasure to introduce our speaker for today's event, Mr. Aris Budi Wibowo. Mr. Aris Budi Wibowo is an data professional with over 5 years of experience in the fintech, e-commerce, and banking industries. Today, we are fortunate to have them here at Pycon APAC, where they will be sharing insight on alternative A/B testing using causal inference to measure impact of your experiment. Please join me in welcoming Mr. Aris Budi Wibowo.
Yeah, good afternoon, everyone. Thank you for coming today to my talk. My name is Aris Budi Wibowo. So I will share to you one of my work in the past that using the other method than A/B testing, that is causal inference to measure the impact of your experiment. So the outline of this talk today is that I will share to you the quick recap of the A/B testing itself. But hopefully, I think most of you already know about the A/B testing, so I will do it quickly just for a refresher. And then also I will talk about the limitations of the A/B testing itself, and then how to bridge the gap using causal inference. And then one of the methods in causal inference that we can use is propensity score matching that I will share to you also, and the use case in the Python, using Python. And then also PSM also have some of its limitations also. And then we discuss of the key takeaways and the recommendations based on that. So here's a quick recap. I know this is an oversimplification for the A/B testing, but please bear with me. But I think A/B testing is the gold standard of doing measurement of the impact of the experiment. So for example, if you have a new product or a new feature that you want to check if that is successful or not, you can use the A/B testing. So basically, A/B testing, at first, you need to define your objective, right? Whether the new product or the new feature is that better or not than the original one. So, and then you try to create two separate groups of users. That there is basically group A, that is the control group, the original one, and then the group B, that is the treatment group, that is the new feature or the new product that you want to test. And then you try to run the experiment, and then you try to measure the results based on the metrics that you already decided before previously. And then you try to analyze using the statistical test to check whether there is a statistical significance difference between the treatment and the control group. But unfortunately, I think there is some limitations from what I read or what I know based on the literature that I research on. So I think I can share to you the three things based on what I know and what I read previously. So the first one in randomization challenges is that because A/B testing heavily use randomization, in some cases we can do that, the randomization. For example, in healthcare, maybe you try to measure the impact of the new drugs. I think it's not fair to just use the randomization because I think maybe the drugs itself is quite dangerous and then life-threatening, etc. I think that's the first thing. And then the second one is the bias and outside factors. For example, in A/B testing, it's not like we take account other factor that push the treatment group to do things. For example, maybe there is some influence from their family or maybe some of their friends, or we don't know yet. And then that's the thing that A/B testing doesn't take account. And then third one, the ethical concerns. I think this one also related to what I said previously regarding the in healthcare, but I think the other things that you need to also consider maybe in education, that when you try to introduce a new teaching method, that I think that's also the key, that maybe A/B testing is not suited for that purpose. So that's why we need to maybe trying to use other method than A/B testing. We need to consider it. So what I want to introduce is that by using causal inference, I think this is the thing that we can bridge the gap between the limitation of the A/B testing and then try to measure the impact of the experiment. So by causal thinking, that basically we go beyond the correlation to uncover the underlying mechanism of the mechanism of the experiment itself. And then in this case, we focus on using the observational data instead. That is basically the historical data that we already have, or maybe the past campaign data that we already done. We can also utilize that purpose. And then specifically in the causal inference, there is one of the topic that is being discussed in randomization. Related to randomization, when randomization isn't possible, we can use the matching process. I think that there are so many matching process methods that we can do, but I will mention only 3 for now. For example, in first one is exact matching. That is, for example, in a treatment group, one of the user, we need to find the user in the control group, the pairing that is have the exact characteristic, such as maybe we consider the education, maybe the past behavior data should be exact one-to-one. But unfortunately, this is quite restrictive and quite difficult for us to do the exact matching. The more flexible that we can also use is that, the other matching process that we can use is that Mahalanobis matching. Is that instead of do the exact matching, we trying to calculate the distance. For example, if we have one user in the treatment group and we try to check what is the match in a control group, we calculate the distance, how far between the distance between the users based on their characteristics, and then we try to calculate what is the shortest distance of users in the control group, and then pick one, and then we will have the matching. And then the third one that I will discuss is propensity score matching. That is basically similar with the Mahalanobis matching, but instead we use the propensity score that is for matching, but the mechanism is quite similar. But what is propensity score matching? Propensity score matching is a statistical technique that we utilize the propensity score of the model for the form matching process. But what is the propensity score that we are being produced? Basically, we are trying to utilize the users' features to predict whether the users have a treatment or not. So basically, think of it as a classification problem. So we're trying to predict whether the users have a treatment or not, and then we will have the probability score, right? And then for a treatment group and also the control group. And then similar with Mahalanobis, we are trying to calculate for one, for example, we have one user in the treatment group. We try to find the user in the control group that there is have the most similar propensity score because we already do the propensity modeling for all of the users, right? And then we try to pair it based on the most similar score. Why propensity score matching like this can be used when A/B testing is not possible? For as I mentioned, randomization can be used in all of the cases that we have. So I think we can consider using the propensity score matching. The second one, we can reduce selection bias by matching individuals based on the propensity, so we can minimize the impact of the bias. And then the third one, we can also control the confounding variables because we already select the variables or the features of each users in our data sets. So we can control the risk of confounding spurious associations. So here are the steps, basically in the propensity score matching. First, we prepare the data. If maybe select the data appropriate for the propensity score matching, and then we try to create the classifications model that is generally maybe you can use logistic regression, but if you want to use other classification models such as random forest or maybe XGBoost, maybe you can also do that as long as it outputs the propensity score, and then do some matching. And as I mentioned, we'll try to calculate the shortest or the most similar users based on the propensity score between the treatment and the control group. And then after that, we calculate the EVAC of the estimations. So we can say that the difference between the treatment and the control group, what is the impact. So here's the use case. I use I think one of the data that is quite familiar in the causal inference studies. There is a lot on the data. There is the data itself is like the historic the list of the users that is have a job training, and also some of them didn't have a job training at all. So we evaluate whether the impact of the job training can have a increase in terms of their earnings. So basically, we're trying to solve whether the job training itself have the impact for the earnings in the future. So here are the columns that we use right now. So basically, that's the treatment that for building the propensity score. And then the other are the features such as age, education, and then also race, and then marital status. This is non-degree, but whether the users have a high school diploma or not. And then the past earnings data in the 74 and 75, and then we try to measure the impact of their earnings in the 78 after the program. So first, we can use the pandas to read the data. So here are the snapshot of the data. So also the snapshot of the proportion between the users that didn't have job training, didn't take the job training, and then the users that took the job training. So basically, there is some differences in terms of the distributions between the control and the treatment group. So after that, as I mentioned, we are trying to build the logistic regression model. So basically something like this. So we're trying to predict the treatment group based on the other features such as the age, education, and so on. And then try to output the propensity score, and then we have the distribution like on this left. I want to note that we are not care. We don't care about the performance of the model, because the thing is we want to make sure that we have the overlap of the propensity score, and also we only care about the covariate balance that I will mention after this. So we don't want to have the the really good propensity model that really differentiate between the treatment and the control group. Otherwise, we don't have any match, and then yeah, we can do the measurement of the impact. And then this is we do the matching process based on the propensity score from both groups. What I use here is that just calculate the distance between the users on the treatment group and to a control group based on the Euclidean distance. So based on the propensity score itself, and then I am trying to match one-to-one. So after the result, we have the exact size of the users on the control and then treatment group at 185. And then after that, as I mentioned, we care about this balance covariance. So basically, we are trying to say that the characteristic of the treatment group must be similar with the control group. How to measure that? By using the standardized mean difference. So basically, we are trying to say that the mean difference of the treatment group features versus the control group features are kind of similar, penalized by their standard deviations, both standard deviations. So here is the function that I use, a standard mean difference, and then they calculate, and then we plot it with the left plot. That's what it's called. I will show you after this, like this one. So basically, as you can see here, this is the red one before the matching, and then the blue one after the matching. So basically, after we did some matching, we can say that the behavior or the features are quite similar between the treatment and the control group. But I think you already noticed that there is the dashed line in the plot itself. So there is a rule of thumb that the differences, the absolute differences in the standardized mean difference is 0.1. But this is not a strict rule. So I think you should think of it, case by case, instead of just strictly want to have an absolute value of 0.1 of the difference. But if you really want to make it the threshold, the difference is an absolute of number of 0.1 below that, you can try the three things. For example, maybe you can try to retrain the model, or maybe choose the different model. If right now I am using a logistic regression, maybe you can use other models such as maybe a logistic model, XGBoost, or maybe random forest. And then the second one, you can also use the caliper matching. So basically, after we calculate the distance between the treatment and the users, maybe the distance itself is not quite acceptable. As I think, for example, if I'm here and then the audience is the shortest to one of the audience is 5 meters, but I only accept 1 meter. So that's the thing that I want to accept. So I assume that there is no shortest audience between me and the others. So that's the threshold that you can also use. And then the last one, maybe you can also try to consider the features that you already being used. Maybe you can consider to use the last features, or maybe you can try to use other features that maybe you can also use later on. And then the last one, after we make sure that the group are similar in the treatment and the control group, we can calculate the average treatment effect based on to answer if the job training itself is impactful or not. So we can calculate it here by creating the regression model. Basically, we're trying to predict the earnings in the 78 based on the treatment labels. Because but be careful, this is on the match data, not on the previous data that we originally have. You can also try to calculate the mean difference. So just calculate the mean of earnings in the 78 in the treatment minus mean in the control group. You can also do that, and we'll also come up with the same numbers. But I want to share also, you can, because we are using the logistic, not logistic, but linear regression, you can also calculate the confidence interval. As I mentioned here, we can also display the confidence interval, so between 574 and 3,000, 3,300. So the conclusion of the experiment itself, the overall impact of the group that have a job training, they have on average earnings 1.9 K dollars more than those who didn't get job training. Okay. So there are limitations regarding the PSM. From what I read and what I know, there are three that I can mention. First one is non-confounders. If we don't include all the relevant features or all the relevant covariates, if there are unobserved confounders that we don't know, that can still lead to bias. And then the second one regarding the reduced generalizability, because unfortunately for the users that didn't have any match, we will leave it out. So that maybe will come to a smaller size of population between the treatment and the control group. So after we are narrowing the sample, after the matching, it may be not generalized well to the whole population that we are talking about. And then the third one is the common support issues. As I mentioned, we don't care about the performance of the propensity model that we create. If we create a quote unquote a too good model, propensity score model, it will have some small overlap. Yeah, unfortunately, we will have some difficulties to match between the treatment and the control group. So here are the key takeaways and recommendations if you want to use all PSM. Maybe because we left out the unmatched of the users, that maybe we can find other users in the other groups that have a similar propensity score. We can consider to penalize it by using inverse probability weighting. The reference of this in detail, I will share it to you after this. And also, maybe PSM is not for your case. Maybe you can also consider other causal inference methods, such as the regression discontinuity, that basically, if you know the actual threshold that you want to check. For example, in a scholarship, maybe you want to check the impact of the scholarship to earnings. For example, the minimum requirement for have the scholarship is 3.5 on GPA, but unfortunately for 3.49, maybe they can have the scholarship rate. So maybe you can use the regression discontinuity if you know the actual threshold that you want to check. And then also the difference in difference. This is basically if you want to check the impact on the time series data based on the treated and untreated data groups that you want to also check. However, if we can use it right, I think PSM can be useful as a data analysis toolkit to measure the impact for your experiment. I think that's all. I think one of the reference that I can share to you, the first one is a causal inference for the brave and true in the section of propensity score. This is quite detailed in terms of in mathematics and also the coding part in Python. This is from the Matthias Facker. He also wrote causal inference in Python. I think you can also refer to that because it's quite interesting, and maybe if you want to know the details, you can also read that. Also, because in R, there is a really good library called Matchet. You can also try to see the documentation of the Matchet library in R. Some kind of interesting read for me. So and then the last one, I think one of the talks from the Michael Jones and the PyData NYC 2019 also mentioned regarding the propensity score matching also. That is quite interesting. I think that's all from me. If you want to read out the slides, or maybe you want to connect, please do. Thank you. Maybe if you have any questions, please do ask. Thank you very much. Yeah.
I have a very simple question.
Yeah. Okay.
So I just try, maybe because I'm not a data person,
Yeah.
I just try to grasp the concept.
Yes.
So you say that PSN is okay. PSN is used. You cannot do the testing. Okay, that's
Oh, sorry.
yeah, I can get it. But the concept that I cannot get is that we are using covariate to to create the cluster between treatment and
Oh
control.
yeah, yeah. I think
Yeah.
instead of covariance, you can say that there is a features. The
Oh.
features of the features of the data that we use. Inside.
Yeah, I just miss how do you, how maybe
Yeah,
I
yeah.
haven't grasped the concept, but
Yeah,
I'm just
yeah.
confused. But how do we find the disease treatment, disease control? I still cannot find the concept.
Okay, so basically, what I'm trying to say is that we have the historical data. So I'm trying to say that this is something like the classification problem that we trying to solve, right? Because as you can see here, maybe the users have other backgrounds such as the demographics or maybe the past transaction behaviors or past behavior data. I say that maybe this will influence the behavior of the users itself if they want to, for example, in this data they will pick job training or not. So that's the limitation of the PSM itself. It's not like we can list out all the features like, but
So the PSN will find a lot of variable and try to improve the
yeah, think yes, yeah. So think of it as we're trying to predict whether the users have a treatment or not based on the features that we already have. So yeah, think of it as classification problem first, because we want to have the propensity score to match similar people in a both groups, right? So for example, if my propensity score is 0.5, what is the closest one closest propensities, sorry, what is the closest one in the other groups that have yes, the shortest in terms of the propensity score? What is, yeah, we can say that maybe what is the 0.5 users in the in other group?
Okay, so I try to rephrase it. So
Yeah, yeah.
imagine you don't know how to determine which one is the group in treatment.
Hmm.
Just use this PSM. The PSM will give us suggestion.
Yeah, yeah.
This is the control system. There's some amount of variables that they.
Not the suggestion, because for example, we already know whether we want to predict whether the job training itself has some impact, right? But fortunately, I think for this case, job training is elective. It's not like people for being forced to do job training, right? It's not like we already know which one is treatment and control, but it's not balanced, right? So that's why we are trying to do the matching here by using the PSN.
The PSM will help us to match.
Yes.
Wow.
Okay. Yeah. Thank you. Maybe other any other question? Yeah, sure.
You want to go back to the slide where you use the classification method? Yeah, now it makes sense why it doesn't have. Yeah, now it makes sense why the classification model doesn't have to be like fully fit, because we don't need it to be fit.
Yes.
We just need it to be like, we just need to measure it.
Yes, yes.
Measure it. Like, would you mind to repeat again if this model fit perfectly? Like, I think it's the next slide, right? The one that has the dash on it. Yeah, this one. If it fit perfectly, then all the orange should be within the border.
I can make sure that, but what I can make sure is that the samples would be smaller. The size of the match would be smaller. That's why I mentioned that that will be difficult if we want to generalize this to the whole population. So that's one of the things that I can make sure. But for the covariate balance, I can make sure we need to calculate it first to ensure that there is a minimal differences between the treatment and the control.
So it is still like case by case.
Yes.
Okay, cool. That's it.
Yeah. Yeah, I think if you guys have have any question? Any other? Okay, maybe you can focus it. Thank you very much. Thank you very much for your time.
Thank you again, Mr. Aris Budi Wibowo, for answering the question and for your insightful presentation. That was an insightful talk. Please give a round of applause to our speaker today, Mr. Aris Budi Wibowo.
Thank you. Thank you.
And please enjoying for another session after this. Thank you.
Thank you. Thank you very much. Oh ya, halo Aris ya.
Ikut komen di postnya Mas Aris.
Oh iya, thank you Mas. Nah,
Ini dong aku rada kurang nangkap tapi aku mau klarifikasi ya.
iya.
Basically tekniknya Mas Aris tuh
Oh ya.